Hello guys, welcome back to my channel Mason African Motives. Still working on revisions on engineering science and two. So we are given the question on energy and momentum, still on the question paper which was written in February 2022. So we want to actually see how we were supposed to answer this question. So if you're new, you can consider being part of the family by subscribing so that you won't miss any of the classes that you shall be having from Mason African Motives. So on question number 3, which is actually on energy and momentum, we were given that a man with a mass of 45 kgs is climbing a steep. Okay, take note, this is actually a steep, guys. From the information we're given, a steep there, which has a distance of 60 meters with a constant velocity. Okay, we are not given the velocity, but it's given it's a constant. And the angle formed between the steep and the horizontal is 40 degrees. Okay, so there's an angle that is formed of 40 degrees. So let's just save the diagram. So the question is asking us to calculate the man's potential energy after covering 60 meters. Okay, so let's just see what this actually is supposed to look like. This is a steep, something like this. All right, and there's an angle that is in between of 40 degrees. All right, so let's come back here together, guys. There's an angle of 40 degrees. Okay, and the man has got the mass of 45 kgs. Okay, so this is where we are going to have something like this. This is where, all right, so it's actually, that is where we are. I'm just representing like an object. In this case, this is the man, but it's actually something like this. Okay, which is our object, which with 45 kgs. So this is 45 kgs. All right, then there's a distance of 60 meters, which is of the steep. This is the distance of the steep. Okay, which means from this point up to this point, this is actually the steep. There's a distance of what? Of 60 meters. All right, then let's see what happened from this information. The question is, calculate the man's potential energy after covering 60 meters. Okay, it's actually supposed to be something, we know that after covering 60 meters, this person is going to be at the top because he's climbing upwards. So it's going to be at the top there because this is going upwards like this. So if it is at the top here, so which means we are actually referring, okay, take note, this is the man's potential energy. All right, so you know that we are going to have a height here in between like this. All right, and the potential energy that we shall have at the top, in this case, this is a 3.1, is going to be mgh. Okay, we know that potential energy is mgh, which is true, but we are not given the height. We have got the mass, the height is not there. G is there, we know that G is 9.8 meters per square second. So where are we going to have the height? So the height is going to be taken from the distance, which is the displacement of what? Of the steep, which is 60 sine 40 degrees. Okay, this is going to be your h. All right, sorry. So the h is going to be 60 sine from the given distance that you have of 60 meters and what, and the height. So actually you can use this Pythagoras. Remember, guys, I mean, not the sine. We know that sine 40 degrees, sine is always opposite, which is the opposite is h over the hypotenuse. The hypotenuse is what? Is 60. So you can actually find this h by cross multiplying. So h is equivalent to 60 sine 40 degrees. All right, so in place of the height, you are going to be substituting 60 sine 40 degrees. Okay, so let's substitute here. So we've got the mass of the man here, if got a mass of 45 kgs, so it's going to be 45 times g, which is 9.8 times h. Okay, in place of h, that's where you're going to substitute 60 sine 40 degrees. All right, so we've got 60 sine 40 degrees. So apply your calculator properly. This is going to be a bigger value. You're going to obtain 1700.8,16015. Yeah, something like that. And this is measured in joules. Okay, so you can actually put this to kilojoules, which is 123. So it's going to be 17,008 kilojoules if you want to convert to kilojoules, or you can just leave it in joules like that, okay? Or you can just write it in kilojoules. That is going to be the potential energy at the top. So you know that potential energy, that is how you actually calculate it using the information that was given. Okay, then calculate the possible velocity of the man going down from the top. Okay, so if this man now is going down, take note, he is at the top before, then now he wants to go down. What will be the velocity? Okay, so we know that the relationship between the potential energy is that the kinetic energy that we shall have is actually equivalent to the potential energy that we have at the top. So if the kinetic energy is equivalent, this is the kinetic energy that you're actually having at the bottom after the movement with the movement that you're having. So we are going to take the potential energy that we obtained before, the potential energy, and equate to the kinetic, because they're equal. This one at the top is equal to the kinetic energy at the bottom. So we had the potential energy at the top, this one. So you can actually use this decimal, or you can actually take this from this part that we have, because this was our potential energy. All right, so which means your kinetic energy in this case is equivalent to 17,008 kilojoules. That is your kinetic energy. So if this be our kinetic energy, it is going to be easier for us to calculate this velocity. Why am I focusing with kinetic energy? Because we know that in kinetic energy there is velocity here, because kinetic energy is equivalent to half mv squared. Remember the formula for kinetic energy. All right, so if it is equivalent to half mv squared, we can actually substitute the kinetic energy. You can write this kilo, just remove the kilo, which is going to be 17,008, which is equivalent to half mv squared. That is the mass. Okay, remember the mass that we had, guys, was 45 kgs. This is the mass of the man here, which is 45 kgs. Okay, so it's 45 times v squared. All right, so you actually want to calculate the value of v, so you can perform your mathematical skills. In this case, remember, guys, your mathematics, you can cross multiply this one and this one, multiply. So if you multiply these two, you're going to obtain 34016, which is equivalent 1 times 45, which is 45 v squared. Okay, then you can divide by 45 like this. Okay, so if you divide by 45, you're going to have v squared, which is going to be 755.91, something like that. Okay, then to find v is going to be square root of what you have on your calculator, just square root of answer. You're going to obtain the value of v. All right, what did I obtain here? Is 27 something, which is 27,494 meters per second, like this. Okay, so this is going to be your velocity. So you're actually taking the velocity from the kinetic energy, because you know that the kinetic energy at the bottom is actually equivalent to the potential energy that you're having, that you had at the top. All right, so that's what we had from this question. Let's see the last question that we actually had. The other question that we had was calculate the possible momentum of the man on his return at the bottom. Okay, the possible momentum. All right, so what is going to be the possible momentum of the man, taking this diagram that we had here, guys? what is going to be the possible momentum. We know that momentum is actually force times distance. So we have from the main here, the force is going to be the weight actually, which is mg. Okay, so we're actually going to apply mg, which is mass times the gravitational acceleration. Then we need the distance. So the main is going downwards here, the steep, which is 60 meters. So definitely I can find the momentum, which is going to be the force times the distance. But the force there is going to be mg times the distance. Okay, that is the weight actually. So let's substitute our weight, our mass, which is 45 in place of m. So it's 45 times g, which is 9.8, times s, which is the displacement, the distance taken, which is this displacement of what? 60 meters. Okay, so we've got 60 meters. So if you multiply properly, this one is a matter of using your calculator properly. You're going to obtain something like 246? It's 264. 26460. Thank you for seeing that if you actually saw this. So it's going to be 26460 Newton meter. Okay, so this is Newton meter. Momentum, the weight is Newton, the distance it's in meters, so it's going to be Newton meter, like that. Okay, so that is the actually the possible momentum that you shall have for this main. So guys, that's, as you can see, that's how they ask these questions, and you need the possible formulas to answer the questions, and the approach. List down your information, the information that you're given, list it down so that it will be able to help you to answer the questions which follow. So it's best for you to list the information that you're given before attempting the question. Okay, so that's it guys from Mason African Motives, working on engineering science and 2 question papers and revision. Till we meet again.